Okay. So sulfuric acid, concentrated sulfuric acid is a very good oxidizing agent, and it can oxidize carbon into carbon dioxide and itself get reduced to sulfur dioxide. So when sulfuric acid oxidize other, itself get reduced to sulfur dioxide. Here you see that sulfur is oxidized by H2SO4. This is sulfur oxidized to form sulfur dioxide, and also H2SO4 itself get reduced to form sulfur dioxide. So here is the only product, that is sulfur dioxide with water. So far as phosphorus is concerned, sulfuric acid is also oxidized phosphorus into phosphoric acid. This is phosphoric acid, and itself get reduced to sulfur dioxide. So all these reactions are important. If any question related to this oxidation process is asked, then the complete balance reaction should be written. That's why these reactions are very important. Here you see that some of the non-metals like carbon, sulfur, phosphorus, etc., those are oxidized by concentrated sulfuric acid. Now we take some example of metals. Those metals are oxidized by concentrated sulfuric acid. Just the copper, metallic copper. Copper is not so reactive element. Uh, it placed much below in the electrochemical series that starts with sodium, potassium, and the bottom of the list where the copper, silver, gold, platinum, etc., those elements are present. So copper is very less reactive metal, though it is less reactive, but concentrated sulfuric acid can oxidize copper into copper sulfate and itself get reduced into sulfur dioxide. Here you see that zinc is also oxidized by concentrated sulfuric acid with the formation of zinc sulfate along with water and sulfur dioxide. So metals can also be oxidized by concentrated sulfuric acid. So concentrated sulfuric acid can oxidize metal, non-metal, and also some of the inorganic substances like HBr, like HCl, etc. Those are also oxidized by concentrated sulfuric acid, some inorganic substances. Now you see some of the inorganic substances. Here you see HI, hydroiodic acid. Hydroiodic acid is oxidized by sulfuric acid with the formation of elemental iodine. HI is converted into iodine and itself get reduced to sulfur dioxide. In each and every reaction of sulfuric acid, uh, where you see sulfur dioxide as a product, only because of the fact that sulfuric acid itself get reduced to give sulfur dioxide. H2S, hydrogen sulfide, is another important reducing agent. It reacts with sulfuric acid with the formation of sulfur, water, and sulfur dioxide. So all these reactions are important. Sometimes it is asked that how you should convert H2S into sulfur, or like hydrogen iodide to iodine, how will you convert hydrogen iodide to iodine, etc. Those reactions can be written. Now, after oxidizing property, another important property of concentrated sulfuric acid is sulfuric acid acts as very strong dehydrating agent. Very strong dehydrating agent. Dehydrating agent means it absorbs water from different substances Here you see some of the organic compounds like glucose, like cane sugar, like starch, etc. All those substances like glucose, cane sugar, this is starch, macromolecules, large molecules. Sulfuric acid absorbs 6 molecules of water from glucose, leaving carbon separate. So, when glucose is treated with concentrated sulfuric acid, the black carbon, the white colored glucose is converted into black after the removal of 6 water molecules. This is another important reaction. This is very important where the cane sugar, if sulfuric acid is added into cane sugar, then cane sugar directly converted into black charcoal, and the 11 molecules of water from cane sugar removes. Here also starch molecules when treated with concentrated sulfuric acid. It also leaves black carbon with few molecules of water released. So concentrated H2SO4 remove water, so many different organic compounds like carbohydrate, like glucose, like cane sugar, etc. So this is one of the important property of concentrated H2SO4 where it acts as dehydrating agent. But concentrated sulfuric acid not only dehydrate the different carbon compounds, different organic compounds like carbohydrate, but it can also dehydrate some organic compounds like formic acid, oxalic acid. This type of acids, they are dehydrated according to the following equations, like formic acid on reaction with concentrated sulfuric acid produces carbon monoxide in the water. And this is very much interesting that concentrated H2SO4 when treated with this is formic acid, and this one is oxalic acid. Okay. When oxalic acid is treated with concentrated sulfuric acid, it produces both the oxides of carbon, that is the carbon monoxide and carbon dioxide, with the water. So sulfuric acid can remove water from different types of organic compounds also. Here you see that formic acid or acetic acid, oxalic acid removes water by the application of concentrated sulfuric acid. Now, concentrated sulfuric acid can also remove the water of crystallization, that is the hydrated salt. The water of crystallization, water from hydrated salt. Like here you see copper sulfate 5H2O. This is the water of crystallization 5H2O. When concentrated sulfuric acid is added to blue hydrated copper sulfate, that is blue vitriol. This is known as blue vitriol. That is copper sulfate 5H2O. This 5H2O is present as water of crystallization. Okay. This water of crystallization is absorbed by concentrated H2SO4, leaving anhydrous copper sulfate. Now this is blue in color. After the removal of 5 molecules of water, this is white in color. So concentrated H2SO4 is very much dehydrating agent, and it can absorb the water of crystallization present in different salts. So these are the different properties of concentrated sulfuric acid. Now we move on to another interesting part of this chapter, that is how will you identify the sulfuric acid? How will you identify a liquid as sulfuric acid? There are some physical properties by which you can easily identify sulfuric acid in the laboratory, but the physical properties should not be considered as the identification test of sulfuric acid. That's why you have to know certain chemical reactions by which you can identify sulfuric acid. Uh, we have already it is known to us that that sulfuric acid having very high density. So mass of sulfuric acid, the same volume of hydrochloric acid or nitric acid, the mass of sulfuric acid is very high. The density of sulfuric acid is near about 1.86 gram per cc. So 1 liter sulfuric acid, this weighs about 2 kg. So the sulfuric acid is very much heavier, and sulfuric acid is also it is having high viscosity. It is viscous. Um, it is sticky. All those properties can be used to identify sulfuric acid. But as we mentioned before, that sulfuric acid, if you want to identify sulfuric acid, then you have to know the identification test, that is the chemical test. Here, one of the important chemical tests by which you can identify sulfuric acid, that the reaction of copper, copper with sulfuric acid gives copper sulfate, and the gas produced, that gas is sulfur dioxide. This sulfur dioxide, how will you identify sulfur dioxide? This sulfur dioxide is identified when the sulfur dioxide is passed through acidified dichromate paper, dichromate solution K2Cr2O7 plus SO2 in presence of sulfuric acid. Then this reaction, it converted into chromic sulfate, potassium sulfate, sulfate, potassium sulfate, jol, etc. These are the products. So here you see that orange color potassium dichromate is converted into chromic sulfate, that is the green color. So concentrated sulfuric acid is heated with copper gives a gas. This gas is actually sulfur dioxide, which turns the acidified potassium dichromate into clear green, that is the chromic sulfate, green color. So this test can be used to identify concentrated sulfuric acid or the sulfuric acid, but this test is not a good test, good laboratory test. In fact, we never use this type of test, but we should use this particular test where the sodium chloride on reaction with concentrated sulfuric acid produce a colorless gas, that is the hydrogen chloride, which gives dense white fumes with the glass rod dipped in ammonia solution. When glass rod dipped in ammonia solution, it reacts with HCl, produces dense white fumes of ammonium chloride. So ammonia reacts with HCl with the formation of ammonium chloride, and this test can be used to identify sulfuric acid. Now in solution, the weight test, these are the dye test or weight test, where the dilute sulfuric acid gives a white precipitate. This is very important. We generally use this test for the identification of sulfate salts. Here we see that sulfuric acid gives a white precipitate of barium chloride solution, which is insoluble in mineral acid. How will you differentiate between barium sulfate and barium carbonate? Just look at this. Barium sulfate and barium carbonate both are white in color, both are precipitate and white in color. But when you add some hydrochloric acid to it, no change. But if you add some hydrochloric acid, then barium chloride and effervescence of carbon dioxide with water forms. So this is carbonate. On reaction with mineral acid, this is soluble. But this is sulfate reacts with mineral acid. It is not soluble. So here you see that so barium chloride solution, which is insoluble in mineral acid. This is barium sulfate and insoluble in mineral acids. So this is one of the important tests for the identification of sulfuric acid. But the last one, that is the dilute sulfuric acid, gives a white precipitate. This is similar type reaction where the lead nitrate is reacts with sulfuric acid with the formation of lead sulfate, which is also insoluble in mineral acids, and all those four different tests can be used to identify sulfuric acid. Some of the tests are in dry test, some of the wet tests. Now, this is all about the different reactions of sulfuric acid. Now, um, already we have discussed that it's powerful dehydrating agent. The dehydrating agent where the wet gas is introduced into this type of machines, and the dry gas is removed, uh, passing through concentrated sulfuric acid. So concentrated sulfuric acid used as drying wet gases. If those gases are not reactive towards the sulfuric acid, then this type of experimental arrangement, now it is powerful dehydrating agent. Now we discuss the last portion of this chapter, that is the uses of sulfuric acid. So sulfuric acid is known as king of chemicals. Sulfuric acid is known as king of chemicals. So sulfuric acid can be used to prepare different types of chemicals like ammonium sulfate, like superphosphate. So these compounds are useful as fertilizer, as fertilizer, or even sulfuric acid can be used to prepare some certain dyes that can be used for color making substances, some pigments that also used in different paints. So sulfuric acid is generally used in different dyes, pigments, and also in paints. Again, sulfuric acid is also used to prepare some of the explosive like trinitrotoluene, TNT, or other types of firecrackers, etc. That is also prepared by the use of sulfuric acid. And sulfuric acid, this is the preparative method for the TNT, trinitrotoluene, what the toluene reacts with concentrated sulfuric and concentrated nitric acid above 60 degrees Celsius temperature with the formation of trinitrotoluene, which is explosive, very much explosive in nature. So this explosive can be prepared by the use of concentrated sulfuric acid. Concentrated sulfuric acid, we have already mentioned that concentrated sulfuric acid can be used to prepare other type of acids like nitric acid, phosphoric acid, or even hydrochloric acid, different salts, sodium salts, potassium salts, etc. Refining, in case of refining of petroleum, where the sulfuric acid is also used industrially for the refining of petroleum. By the use of sulfuric acid, you can remove the different impurities that is present in petroleum. Or sulfuric acid used as the pickling agent. Pickling means if the metal is actually corroded. Corroded means it reacts with different chemicals present in the atmosphere and changes its property. Then that metal should be washed when dipped into concentrated sulfuric acid. So this is known as pickling of metals. So this is another use of sulfuric acid. So this is all about sulfuric acid and this particular chapter. We have completed this particular chapter. Now we want to start another chapter, that is acid base and salts. Just give me 1 or 2 minutes so that I just search for the presentation of acids. Presentation of acid base salt. Okay, then we should start a new chapter, that is acid base minute. Okay, then acid base salt. The scope of the syllabus is the simple definitions of acid, bases, and salt, their characteristics, their properties, their different types of acid, base, salt, the pH, one of the important uh, part of this chapter, that is the pH calculation or the comparison of pH, and the process to prepare different types of salts or methods to prepare for the preparation of different types of salt. Let's start with acid. This particular terms comes from the acids are generally present in citrus fruits. Actually, they contain citric acid. This type of fruits, they contains citric acid. So this is initially the term acid means this term coming from Latin word means sour. Okay, so acid derived from the Latin word that means sour, like some of the organic acids, like those present in living organism, that is the oxalic acid. Here is tartaric acid, here is oxalic. It is not oxalic acid, this is vinegar. Okay, this is acetic acid, not oxalic acid. Acetic acid. The picture given that vinegar. What is vinegar? Vinegar is the 7% acetic acid is known as vinegar. Now it is tartaric acid and tomatoes that contains oxalic acid. And acids are generally see this generally taste, it is sour, but I never taste with sulfuric acid or nitric acid. Generally we talk about the organic acid, those present in different fruits. But the sulfuric acid and nitric acid also, I think that will be also sour in nature. But anyone can taste it to confirm. So far as bases are concerned, bases like baking soda or the base present in soap or different types of powder, washing powder, etc., they are bitter in taste. They are generally base. They are not sour. They are bitter in taste. So this is just introductory part of this chapter. Here you see some of the metallic oxides and hydroxide. They are generally bases, like sodium oxide, metallic oxide, or sodium hydroxide. They are generally bases. Those are present in liquid detergent also. Ammonium salt, etc. Those are present. So the acids and bases are directly attached to our daily life. Now we consider that if acids are added into water, then what happens? If acids added into water, then acids produces H plus ion that attached with water with the formation of hydronium ion. This is one of the important aspect of acidic character of any acid. Like here you see that when hydrochloric acid is added into water, what happens? Then hydrochloric acid, it gives H plus. That H plus is attached with water with the formation of H3O plus and formation of Cl minus. So acids generally when added into water, they produces H plus. But H plus is not like that. It is very much unstable. So H plus get attached with water with the formation of H3O plus. That is generally known as hydronium or hydroxonium ion. So acid, if you want to define acid, then acid is a compound which when dissolved in water its hydronium ion, that is the H3O plus, as the only positively charged ions. There may be formation of negatively charged ion also, but the only one positively charged ion, that is the H3O plus. So an acid is a compound which when dissolved in water it's the hydronium ion or hydroxonium ion, you can say. So this is the definition of acid. Now the question already we have answered, that what happens when HCl is added into water and why. Now HCl, how you should consider HCl with respect to its bonding. HCl is covalently, hydrogen and chlorine is covalently bonded. This bond is covalent. But some of the covalent compounds, those are considered to be polar covalent. Okay, polar covalent. When when one electronegative atom get attached to electropositive ion, the more electronegative atom draws electron pair towards itself, creating the slightly negative charge over the electronegative atom and slight positive charge over the electropositive atom. What I should say? That is, hydrogen and chlorine, they are covalently bonded with each other. But because of the fact that chlorine is much more electronegative with respect to hydrogen, then chlorine draws electron pair, that is the bonded electron pair, towards itself. So because of the fact that chlorine draws electron density towards itself, so it carries slight negative charge, and on the other hand hydrogen carries slight positive charge. This is called the polar character. This is called the polar character. If any bond formed in such a way that shows some polar character, that is a negative or positive character of the respective atoms, then that type of bond is known as polar covalent bond. Here a hydrogen chloride or HCl is considered to be polar covalent bond. Now this polar covalent bond, this compound when added into water. Now what about water? Water, it also contains polar bond because oxygen is highly electronegative and hydrogen is comparatively electropositive. So oxygen draws electron pair towards itself, creating water is also is polar in nature. So when HCl added into water, water is also polar and HCl is also polar. So as we all know that polar easily dissolves in polar solvent. So it gives H plus, and that H plus is attached to water with the formation of H3O plus and Cl minus. So when HCl is added into water, then HCl reacts with water with the formation of H3O plus and Cl minus, and as a result HCl behaves like acid because the species when dissolved in water, when it gives H3O plus, then it should be termed as acid. So HCl is considered to be acid. Now similarly, we can define base. Now a base is a compound. Base is a compound which reacts with hydronium ions of an acid to give salt and water only. Now base is a compound. Base is a compound which gives rise OH minus. It reacts with hydronium ion with the formation of water. So if we consider base like sodium hydroxide and acid like HCl, so base is such a substance that reacts with acid with the formation of salt and water, that is sodium chloride plus water. So base is such a compound which reacts with hydronium ions, hydronium ions to form salt and water only. So this is the definition of base. Bases are generally metal oxides or hydroxides. Now here you see that copper oxide or copper hydroxide, these are metal oxides and hydroxides. Because of the fact that copper oxide and hydroxide, they are base, they react with HCl with the formation of CuCl2 plus H2O, or even copper hydroxide reacts with sulfuric acid with the formation of copper sulfate plus water. So bases are such a substance that reacts with acid to form salt and water. Now move on to the next topic, that is a base and the alkali. Bases are oxides and hydroxides of metal generally, including ammonium hydroxide. Ammonium hydroxide is not the metallic hydroxide, but ammonium hydroxide, ammonium is metal-like radical. Ammonium is positive, it is metal-like radical. So when bases are dissolved in water, then it is called as alkali. But there are some bases which are insoluble, which are not alkalis. If bases are soluble in water, then they are termed as alkali. But if they are not soluble in water, they should not be termed as alkali, like zinc oxide, like lead oxide, copper hydroxide, lead hydroxide. All these compounds are hydroxides of metal, but they are insoluble in water. Because of the fact that they are insoluble in water, they should not be termed as alkali. Because only those bases are termed as alkali because when they are soluble in water, like sodium hydroxide, potassium hydroxide, they are base as well as alkali. If the bases are soluble in water, then they are termed as alkali. So sodium oxide or sodium hydroxide, magnesium hydroxide, these are generally termed as base as well as alkali. But zinc oxide, lead oxide, copper oxide, etc., they may be termed as base but not alkalis because they are not soluble in water. So what is alkali? Alkali is a compound when dissolved in water, they produces hydroxyl ion as the only negatively charged ion. If you consider any alkali, then alkali dissolved in water to form hydroxyl ion as the only negatively charged ion. It dissolved in water. Like sodium hydroxide, it produces Na plus and OH minus. So sodium hydroxide should be termed as alkali. Here you see sodium hydroxide, it dissociates with the formation of Na plus and OH minus because of the fact that it gives OH minus. Then sodium hydroxide should be termed as alkali. Now, previously we have mentioned that water-soluble bases are called alkalis. So, all alkalis are bases, but all bases are not alkalis because some of the bases are insoluble and those insolubles are not alkalis. But if at all it is alkali, then previously it is also base. So all the alkalis are bases, but all the bases are not alkalis, because some of the bases, if they are insoluble in water, then they should not be termed as alkali. So this is something about the base and the alkali, differentiation between the base and the alkali. Here you see some of the alkalis like sodium hydroxide, potassium hydroxide, even calcium hydroxide or ammonium hydroxide. These are alkalis and they are also bases. Now how you should dissociate sodium hydroxide? This is very much easy. Sodium hydroxide aqueous, written as Na plus aqueous plus OH minus aqueous, because sodium hydroxide added into water. How potassium hydroxide dissociates in water, that is also similar way. Potassium hydroxide aqueous, potassium plus aqueous plus OH minus aqueous. This is the dissociation of KOH in water. Here calcium hydroxide CaOH whole 2 aqueous, calcium 2 plus plus 2 OH minus. They are also aqueous. All are soluble in water, so they are bases as well as alkalis. Ammonium hydroxide. How ammonium hydroxide is soluble in water? Ammonium hydroxide, when dissociates ammonium plus OH minus. This is the dissociation of ammonium hydroxide. All the species gives OH minus in aqueous solution. They are alkali as well as they are base. Now we move on to another important part of this chapter, that is the classification part. How you should classify the acids. There are so many methods, so many, what I should say, so many criteria, depending upon which they can be classified. Like number one, depending upon the source, so where from that acid comes. Either it is come from organic source or inorganic source. Or depending upon their strength. Strength means its power. Depending upon their concentration. Concentration means dilute or concentrated, etc. Depending upon their molecular composition. What are the elements, what type of elements present in its composition, etc. And another one, that is the basicity, acidity, etc. Depending upon the acidity or basicity, etc. So first of all, we should consider depending upon their sources. Now source means there are two different types of source of acids. Some acids are known as organic acids. Organic acid means they have organic source. Okay, they have organic source. These acids are usually obtained from plants, and generally they contains carbon. Generally they contains carbon. So these are organic acids like oxalic acid, acetic acid, tartaric acid. These are known as organic acids. Now, inorganic acids. Which acids are known as inorganic acid? They are generally obtained from minerals. They do not contain carbon except carbonic acid. Generally, they are called as inorganic acids because they usually obtained from different types of minerals. Like HCl. HCl obtained from sodium chloride. So sodium chloride, HCl should be termed as inorganic acid because it comes from rock salt. So hydrochloric acid, nitric acid, sulfuric acid, all those acids are known as inorganic acids. Now, depending upon their strength, some of the acids are termed as strong acids and some of the acids are termed as weak acid. The strong acid which gives the greater number of H plus or H3O plus ion when dissolved in water. These acids are nearly completely dissociates with the formation of H plus or H3O plus. Like sulfuric acid, hydrochloric acid, they are near about totally dissociates. The acids which are totally dissociate or near about totally dissociates gives large number of H plus or H3O plus when dissolved in water, then they are termed as strong acid. Strong acid, that is, strong acids are those which dissociates completely in aqueous solution and thereby produces high concentration of H plus ion or H3O plus. Those acids are termed as strong acid. Strong acid dissociates completely in aqueous solution. There is no undissociated molecule of acid. How sulfuric acid or nitric acid dissociates in water? This is very easy. Sulfuric acid, H2SO4, when or even nitric acid, etc. This type of dissociation in water observed in case of sulfuric acid or nitric acid or even hydrochloric acid, which is already mentioned. So some acids are strong acid and some those are incompletely dissociated, partially dissociated. It's known as weak acid like acetic acid, carbonic acid, etc. These acids are known as weak acid because they are partly dissociated. They are partially dissociated. They produce generally low concentration of H plus or H minus. If they partly dissociates, then H plus or H minus concentration will be less. If they are fully dissociates or totally dissociate, then their H plus or H3O plus concentration will be high and then it will be termed as strong acid. Acetic acid, carbonic acid, formic acid, etc. How they dissociates? Like if you consider acetic acid is CH3CO plus. CH3, it contains H, reacts with H2. with the formation of CH3CO minus H3O plus, or even carbonic acid H2CO3. HCO3 minus plus H3O plus. This is the dissociation of carbonic acid H2CO3, or even formic acid. The formula of formic acid is HCOOH. Water. The formation of HCO minus plus H3O plus. These are the sum of the dissociations of acetic acid, carbonic acid, formic acid. And so many organic acids are there. They can be dissociated in this way. Anhydrous acetic acid, the information, note information. Cooling, it forms crystal of glacial acetic acid. So acetic acid is liquid, but when is converted into crystals of acetic acid? Now, strength of acids, we already mentioned that the strong acid and the weak acid. Now, in case of alkali, we can also use these particular terms like if the alkali is concerned, that depends on the concentration of OH minus present in the aqueous solution. If the concentration of OH minus is very high, almost totally dissociate to a high concentration of hydroxyl, and then it is termed as strong alkali like sodium hydroxide, potassium hydroxide, even magnesium hydroxide. They are strong alkali. Like lithium hydroxide, sodium hydroxide, potassium hydroxide. Their dissociation quite easy. Lithium hydroxide dissociate lithium plus plus OH minus, or sodium hydroxide Na plus plus OH minus, or even potassium hydroxide K plus plus OH minus. So these are very strong alkali, sodium, potassium, lithium, etc. But weak alkali, they are partially dissociate in aqueous solution, thereby producing low concentration of hydroxyl. Low concentration hydroxyl produces like ammonium hydroxide, calcium hydroxide. Two examples are there. Ammonium hydroxide, NH4OH. Partly dissociation means reversible sign. NH4 plus plus OH minus, or the calcium hydroxide. Calcium 2 plus plus 2OH minus. This is a dissociation of ammonium hydroxide and calcium hydroxide. These are weak alkali. So degree of dissociation is one of the important terms that can be used to distinguish between the different weak. Just think about the fact that if you consider strong alkali or strong acid, it is 100% dissociated. But when you consider the weak acid or the weak alkali, then they do not dissociate 100%. So dissociation may be 80% or dissociation may be 10%, 20%. So how you should consider the strength of the different weak acids or weak alkali? So in order to compare them, we use the degree of dissociation or degree of ionization, where the number of acid or alkali molecule ionized divided by total number of acid molecules taken into 100. This is only because of the fact that the compounds which are not strong, there are a long range of compounds, they can be considered as weak. So if an acid 5% dissociated, then it is considered as weak, or even 65% dissociated, that is also considered as weak. Below that of 100% dissociation, all are considered as weak. So if you want to compare the if you want to compare the strength of different weak acids or alkali, then you have to use the degree of ionization. Now, depending upon the concentration, there are two types of acids or alkali considering the concentration. Like concentrated acids. Concentrated acid means it contains very negligible amount, very less amount of water, like 98% sulfuric acid. 98% sulfuric acid means it contains 98% sulfuric acid and 2% only water. This is concentrated acid. But the dilute acid is an acid relatively low percentage of acid in its aqueous solution. It contains high amount of water, very less amount of acid. These are known as dilute acids. Similarly, concentrated alkali means it contains the high percentage of alkali in aqueous solution, and the dilute alkali means it contains very low percentage of alkali in aqueous solution. Concentration is less than 1 mole per liter is considered to be dilute. 1 mole if present less than 1 mole per liter present is known as dilute alkali. So concentration always expressed on the basis of this unit, that is the mole per liter. This is the unit by which we express the concentration. So today we stop up to this, because after that so many properties of different acids and bases are there. So next day we should consider the acids and base. So till then, good night and bye.
Bye, sir. Good night.
Bye.